welcome to your quick little lesson on parabolas. Today in class, we went over the homework over the y equals, and we talked about the parabolas that are x equals. So when it's y equals, it gives us a parabola that opens up or down, and when it's x equals, it gives us a parabola that opens up left or right. So let's take a look at, let's take a look at the notes you were given today in class. We know that this point here that is equidistant, this P, from the vertex, this point is called the focus. So this is our focus, and this line is the directrix. And when we talk about parabolas in terms of being a conic section, we define the parabola as the set of all coplanar points who are equidistant from a fixed point called the focus and a fixed line called the directrix. Now, we looked at the video that showed us the graphing of that in class today, and let's take a look at this. If this is P and this is P, this distance from here to here would be 2P. And this distance from here to here would also be 2P. So how do we know that? We know that because these are equidistant, and because if this is 2P, this would have to be 2P. And since this point is 2P away from this line, then this would have to be 2P away from this line. So if we looked at that, a quicker way to graph, if this is 2P, then all the way across would be 4P. So it would be 2P on either side. The focal width, the width right here where the focus is, the focal width is 4P. So if we had a graph, and let's say you knew the vertex was the point 3, 1, and we knew that P was 2. We could sketch a quick graph by going over 1, 2, 3, going up 1, vertex. Well, if P is 2, then our focus is up 2, and then we know 2 to the left. If P is 2, then we double that, 2P, 4 to the left, 1, 2, 3, 4. That's 2P, and 4 to the right, 1, 2, 3, 4, would give us another point, and wow, we graphed it nice and quickly. So, it's really easy to graph a parabola knowing P, because from the focus, if we go 2P in either direction, we find points that lie on the parabola. Okay, so now let's look back generically in terms of any parabola. If it's y equals and it opens up, the vertex is HK. The focus is where we go up P from this. Well, up affects our y, so we'd add P to that. The directrix is where we go down P, which means we're subtracting P. We're subtracting P from that K, and this is a line. It's a horizontal line, so it's y equals K minus P. Now, today in class, we also approached the parabolas that open left or right. When they open left or right, they're x equals, and it's the exact same form if we take a look. It's x equals 1 over 4P, y minus the y value at the vertex squared, plus the x. Now, we're also going to become familiar with this 4P. 4P. Well, 4P, look at there. 4P. This is conic form. And you see, if we solve this equation, it's really simple to put it in this form. If we multiply, if we move the K over and then multiply by the 4P, we have it in this form. This is called conic form. And whenever I ask for conic form, that's what I'm looking. And this is vertex form. And for most problems, I'll take either form. Okay, now in this one, our focus, we listed it here. Our directrix, we listed it here. We'll do the same thing over here. When it opens left or right, we can have x equals 1 over 4P, y minus k squared plus h. Now if we solve this, move the h over and multiply it by the 4p, this is conic form. So this is vertex form, vertex form, conic form. Once again, I'll take either. So when we open here, here's our vertex. This is still our P. Okay, so this is our focus, and this is our directrix. Now, if we notice, with a parabola that opens this way, our directrix is a vertical line. A vertical line is x equals. Our vertex is still HK. Our focus, we are moving left and right this time, left and right. So for the focus, we're adding P, and since we're moving to the right, we're adding that to H this time. When we were moving up and down, we added it to the Y. Here we add it to the X. And the directrix is the H minus the P. That takes it back. And once again, if we knew the vertex and we knew P, we could plot the vertex, plot the focus, and then double P, 2P, in either direction to get those extra points. Okay, the other thing I want to talk to you about is, real quickly, completing the square to put it in vertex form. 2 quick examples and then we're done. The first one is something you're very familiar with because we've done lots like this. To put this in vertex form, we would move the 47 over. We would factor out the 2. That is x squared. Now we would complete the square by adding 25 here, but we know it has a weight of 50, so to keep it balanced, we'd add 50 to the other side. This would become y plus 3. This is x minus 5 squared, and so in vertex form it looks like this. So could you graph it from what you know about vertex form? Sure. Could we also graph it by what we know about where the focus would be, where the directrix would be? We could do it all. So if we were to graph this, whoops, wrong button. Let me back up. I meant to hit my graph. There we go. We know that the vertex of this one is the point 5, negative 3. So we'd go over 1, 2, 3, 4, 5, down 3. There's the vertex. We know that 2 equals 1 over 4p. So when we get 8p equals np equals 1/8. So we know that the focus would be up 1/8. So the focus would be up 1/8, which would be 5 and negative 2 7/8. The directrix would be down 1/8. So it would be y equals negative 3 1/8. Okay, and we know this one's opening up, so we could graph everything we have now. We're just going to make this close because 1/8 is just close. Now, the focal width doesn't really help us on this one so much, because when we double an 1/8, we get a 1/4, so we'd go a 1/4 in either direction. So this one might be best to go back to what we know about moves. If I go over 1, I go up 2. And then we graph it. Okay, the next one I'm going to show you is x equals, and that way we can see one graph of this also. So x equals, and so we're going to complete the square here. We're going to move the 3 over. We're going to write this as a perfect square trinomial by adding 9 to both sides. So now we've created a perfect square trinomial. So this becomes x plus 6 equals y plus 3 squared. So x equals y plus 3 squared minus 6. So this one is x equals. When x equals is positive, when our a is positive, it's going to open right. When we have an x equals parabola and we have a negative a, it's going to open left. This a is positive. So we know that our vertex is, what's added to the end this time is your x. This, the opposite of this is now your y. So my vertex is negative 6, negative 3. P is equal to, all right, let's find out. So we say 1 equals 1 over 4p, So we get 4p equals 1, so p equals 1/4. So we know p is 1/4. So now we can get the focus and directrix. Now, since the A is positive, we know it's opening right, so we know the focus has to be inside. The directrix is going to be back here. So we're going to add that to our x. So the focus will be -6 plus 1/4. The focus will be -5 3/4, -3. And the directrix it's a vertical line, so it's going to be x equals. We're going to subtract that 1/4, so it's -6 1/4. We're subtracting the 1/4 from the x, subtracting it. And we could graph this by plotting our vertex, we would also plot the focus and directrix because we're in the conic section. We're going to label all our important conic parts. And then we can just do normal moves. So let's talk about how that would look for this one. All right, so our vertex is -6, -3. And we're here. Now if we do it with moves, instead of going over and up, we're going to go up and down and over. And we're going to go up and down and to the right. So if we go up 1, 1 squared is 1. If we go down 1, 1 squared is 1. If we go up 2, 2 squared is 4. If we go down 2, 2 squared is 4. Now, if doing 2p would be helpful, we could also do that. Sometimes it's helpful to move back and forth from the focus. Sometimes it's not. Our focus is in a hard-to-tell spot. So in this case, I don't know that it would be that helpful. There's our focus. There's our directrix. Okay, good luck tomorrow.